Hi everyone, this is Dr. Zanaria, and in this video I'll be explaining this tutorial 5, which you can find in my presentation slide. So here the question is calculate Z, HR and SR by the Lee-Kesler correlations and generalized second virial correlations for A, benzene at 575 Kelvin and 30 bar, and B, and butane at 500 Kelvin and 50 bar. So in this video I'll be showing you the solution for A only. For B you can try by yourself. Okay, so to use the Lee-Kesler correlations, you need to find the reduced temperature and reduced pressure. Okay, so to do that, okay, so this is what I have written down on my paper. Okay, so we have benzene at 575 Kelvin and 30 bar. So first you need to find the TC, critical temperature, PC, critical pressure, and also small omega for benzene, and you get these values from appendix B. So where is appendix B? So you can open your textbook. Right, so this is appendix B, properties of pure species. So here is the table B1. Okay, so our species is benzene, so you find benzene. So benzene is here. Okay, this one benzene. So you can read the values for benzene. The small omega is here. Okay, 0.21, and then next you have TC 562.2, and then this is PC 48.98, which I have written on my paper here. Okay, so all the values TC, PC and small omega. So then you can calculate TR, which is T over TC. Okay, 575 divided with 562.2, we get 1.0228. And then for PR is P over PC, 30 over 48.98, we get 0.612. And we round up these two values. Kenapa kita nak round up dia? Because we want to have we want to use the Lee-Kesler correlation table more conveniently, because the values of 1.02 and 0.6 can be found, the exact same numbers can be found in the Lee-Kesler correlations table. So the Lee-Kesler correlations you can find from appendix E if you are using 7th edition book as my book. If you're using the 8th edition book, it's in appendix D. So appendix E, okay, so this is appendix E, the Lee-Kesler generalized correlation tables. Okay, so you want to find your Z0 and Z1. Okay, so our TR just now is 1.02 here, and your PR is 0.6. So you can read directly from the table. So this is 1.02 here, and then this is 0.6. So your Z or Z0 is 0.7761. And similarly, the next page is showing you the values for Z1. Okay, so you read TR is 1.02, and then PR is 0.6. So it's here. Okay, so it's here, negative 0.0277. Okay, so here again I have listed the values on my paper, Z0 and Z1. And so the formula for Z is Z equals Z0 plus small omega times Z1. So you just substitute all the values, and we get here Z equals 0.7703. And then for the values for the residual enthalpy, right? So the formula for residual enthalpy, HR, this is the formula, yeah, from the textbook. You can refer your textbook if you don't remember. Okay, so this is in chapter 6 here. Okay, my book is the 7th edition book. Okay, so this is the formula. Okay, so HR over RTC is this one plus small omega times this one, and then for SR over R is given here. So this value HR0 over RTC, HR1 over RTC, SR0 over R, and SR1 over R can be obtained from the Lee-Kesler correlation table just now, very similar to Z. Okay, so you just need to continue flipping your pages. Okay, so you have Z1, and then this is still back to Z0 because of the different TR PR values here. We have the bigger PR values, and then next is Z1. Then here you can see this is for HR0 over RTC. So same goes. You find your TR just now is 1.02, sorry, and then the PR is 0.6 here. So this is our value, negative 0.708. Okay, and then for HR1 over RTC, it's here 1.02, and then PR is 0.6, so it's here. Sorry, I cannot really show you. It's actually sorry, where is it? It's actually here. Okay, this one, negative 0.594. Okay, so we just sub into the equation. Okay, this is your HR0 over RTC plus small omega times HR1 over RTC. So here we get negative 0.8327. So for the final answer, you need to multiply the values, the value for here times, you need to multiply with R, 8.314, and then your TC, which is 562.2. So the final answer is negative 3,892 joule per mole. So this unit, joule per mole, depends on the value of R that we use. So here we use the standard R for SI unit, so our unit for enthalpy will be joule per mole. So similarly, for SR over R, you simply continue the same appendix. Okay, you flip. So here you can see this is SR0 over R, and then you read TR 1.02, and then PR is 0.6 here. And then next page is for SR1 over R. So I have written my answers here. Okay, so this is SR0 over R plus small omega times SR1 over R. So this is the value that we get from the appendix just now. Okay, and here we get negative 0.6069, and so for the final answer for SR, you need to times the value here with R. Okay, so this is negative 5.046 joule per mole per Kelvin. Okay,